Good afternoon or morning, everybody. Thank you for all joining in. Let's give it a couple more minutes for people to filter in, but we plan to start right on the mark at 1 o'clock today. Perfect. And Nicola, just confirm you can see my screen all right?
Yes, thank you.
Awesome. Cool. Just give it another minute or two. Just wait for some more people to hop on before we jump in today. Thanks, everybody that's joined in so far. Good to see some familiar faces in the crowd so far. Okie doke. All right, well, I guess we'll get into it now. Hello, everybody. Thank you so much for joining the Meeting California Full Trash Capture Requirements webinar, where we're going to be looking at going from compliance to implementation. My name's Braden Van Leer, and thanks for joining me today. Just for a bit of quick housekeeping to start us off. First thing is we're going to have a couple polls that are going to come through throughout the presentation. So if you would please answer those as you can. A little bit of information is going to be really helpful for us, especially if we're looking at doing future webinars and things like that. And if you do have questions, please just add them to either the Q&A or the chat, and we'll get to those at the very end. For those of you who are interested in reviewing or want to share this with other people, we will have a recording available after that we'll send out to you guys. And if you also just want the specific slides, because there's some that have a lot of information on there, and we won't have enough time to go through every single bit of it in detail, those are available on request, so to help you refer to later on. So after a quick introduction, today's agenda is going to involve a compliance overview, including full trash capture regulatory context, as well as a brief look at full trash capture in California. We'll also be taking a look at trash capture device types, design, as well as a bit of operation, looking at the flow design criteria, maintenance, and whole of life costs. From there, we're going to go ahead and shift over to procurement, where we'll look at competitive versus sole source bidding, and then we'll look at some pre-bid information as well as specification details that you can include to help make sure the project goes well. After that, we'll look at a couple real-world examples and see how best practice can lead to preferable outcomes. So just to start, for a bit of background on Enviropod, Mike and Greg, who are pictured below, they started Enviropod 30 years ago as a way to protect waterways through science and innovation, as they saw that humans were already creating an adverse effect on the waterways. And throughout this time, Enviropod devices have been continuously researched and tested and improved, and they're evolving into a globally accepted, or they have evolved into a globally accepted solution for pollutant capture within stormwater runoff. And so all of our products are tried and tested in the real world as well as in the labs so that they can meet stormwater regulations and provide better urban water outcomes. And so just a bit about me. I love hanging out in nature, and growing up in Utah gave me a real appreciation for our environment. And in my early 20s, I made the decision to go and study in New Zealand. And in my last year of study, I landed an internship with Stormwater 360, which is part of the Enviropod group. And as part of the internship, I counted all of the trash that was in 34 litter traps over the course of an entire year. And as you can see, that ended up consisting over 25,000 pieces of trash, and most of that being plastics. But after my internship, I got to stay on with the company, and I was designing systems in Australia, Canada, New Zealand, as well as in the US, primarily in California. But now I'm located here in Southern California, and I've become a sales engineer, and I've had the opportunity to work with a lot of great people in a lot of cities since. But now, so as we start, we want to get into a little bit of regulatory context. A little bit dry for these first two slides, but we'll try and just get through it. But I just want to make sure we set the ground, set the ground rules properly. And so most trash requirements, TMDL-driven stormwater requirements are ultimately implemented through MS4 permits. These requirements might start as a TMDL statewide policy, local ordinances, or water board orders, or they can even come through in just local design manuals. But the thing is the MS4 permit is usually the main compliance vehicle, and it sets forth the targets for a specific region. And so for California, the nuance is also very important. The trash amendments apply statewide after their adoption in 2015, but they're not self-implementing. That means they need to be incorporated to the applicable permits. And according to a report by the California Stormwater Quality Association, while many cities are on track, some MS4 permits have not still fully incorporated the trash amendments. And that kind of creates a bit of an uncertainty as to how exactly they're going to comply with this upcoming 2030 deadline. And so part of why I bring this up is, this kind of pressure can lead to quick decisions by municipalities that might not be in the best long-term interest for permittees, and that's kind of why we're doing this webinar, is we're trying to make people aware and give them that information so that they can make sure that they're not saddled with something that's not going to be in their best interest. And so while many of the California MS4 permits are moving towards regional watershed-based frameworks, there are still differences in how those requirements are achieved. If you can look at Los Angeles and San Francisco Bay, they were early adopters and are now generally understanding and used to the requirements, trash capture requirements under the regional permit. Whereas Santa Ana and the Central Valley are kind of following in the same direction, but they're not quite at the same pace as them. And they're moving into that regional permit, but for different reasons. So Santa Ana is trying to unify 3 county-based permits across a heavily urbanized watershed, a single urbanized watershed, while Central Valley is using a broad region-wide permit. This way, it creates consistency and flexibility across a very large and varied inland region with a lot of, there are some big cities, but there's also a lot of farmland and rural areas to consider. And so kind of with this move to regional permits, or with looking at these regional permits, it's good in that it can make trash capture requirements more consistent and easier to document. But it's also good to note that they do raise expectations around planning, monitoring, adaptive management, and long-term maintenance records, which is generally good, but it can be a bit administratively heavy when you're getting that set up. But I think it's kind of a good way to go, because to also give like a little bit more context here on the right, you can see a map of the regional water boards, and on the left is a map of watersheds in California. And as you can see, there's a little bit of, you can see kind of that's how the the lines on the water boards are drawn. A lot of you know that, but it wasn't common sense to me when I first heard about it. But you can see that some of the watersheds are quite large, and they're going to span over many, many, many cities. And I think this is something really important to keep in mind when you're looking at these full trash capture requirements, is that stormwater doesn't end at the city or county borders. And so part of the benefit of aligning cities within the same watershed is that the expectations are the same. so that one area, so you don't run into a situation where one area with a loose or ineffective plan, isn't capturing what they're supposed to, and it actually ends up adding the load to somebody else downstream. And so with this in mind, how do cities typically comply with trash capture requirements? With the trash amendment in California, they're split between track one, which involves using only full trash capture certified systems in medium or in moderate, high, and very high priority land uses that are maintained yearly. And track two is where you can use a variety of methods to achieve equivalent full capture, such as maybe like a mix of street sweeping, trash capture devices, and then like local beach or river cleanups. It often has more reporting requirements, and depending on the method used, it can be hard to justify or quantify the received benefits for going track two, such as especially if you were to include something as like anti-litter marketing. And looking at the different full capture device types, there are a lot of different full trash capture devices available, from large end-of-line systems to catch basin inserts like you can see here below. As most cities have their high priority land use areas in existing sites and infrastructure, retrofitting catch basins is often a lot more practical than finding a road that you can dig up to put into a large end-of-line system. And so with this in mind, we are focusing on projects and bids that are utilizing at-source solutions today. And so, just to clarify a bit more, at-source treatment is defined as just that, treatment at the source. The reason why we here at EnviroPod like it is because this means that the devices are placed in catch basins and they take rainfall runoff and capture pollutants before they get downstream. And so while there might be some perceived benefits of end-of-line systems, one of the key differences between these devices is at-source treatment captures material and holds it in a dry environment. We know that when, materials in a wet environment and it's churning and running into each other, it breaks down, and then you can lose it downstream. And also, as you can see illustrated on the right, a lot of material and plastics don't float, and so some systems just won't target a large portion of trash that might be hiding just underneath the surface. And so while at source treatment devices might seem very simple at first glance, there are a lot of considerations that need to go into the design of these products to ensure that the best outcomes and the lowest whole of life cost for these devices is achieved. It all starts with regulatory compliance. I mean, it's a bit of a given since that's kind of the reason why a lot of us are doing anything at all. But hydraulic capacity is a part of those regulations, and it is often overlooked during trash capture projects. And making sure that the devices work to this hydraulic capacity is also a key thing relating to the trash retention. Making sure that the devices can actually hold on to the material that they're capturing in typical runoff events. The devices, of course, also need to be able to fit within the inlets and be able to be maintained, and the catch basin needs to be accessible for other maintenance operations down the line. And so when you kind of put all of this together, it eventually becomes conglomerates into a durability and life cycle value. So that, again, I'll probably say it quite a few times during this, but the whole of life costs, is key. You want this project to be successful for years to come because you're going to be maintaining these a lot longer than after they're installed by the 2030. So looking a little bit closer at the hydraulic requirements, the California Water Board requires that devices that are installed in catch basins can capture the 1 year, 1 hour storm. And so you can think of this kind of like as a benchmark storm. Engineers need consistent ways to compare devices, so regulators use what they call the 1 year, 1 hour storm. And it's not literally a storm that happens exactly once every year. We can see the weather is known for being very unpredictable, but it does mean a storm of that intensity has a roughly 1 in 1 chance of occurring in any given year. And so for trash capture devices, The state water board specifies trash capture flow rates, but it actually doesn't account for peak flow conditions. And there's a lot of variability in how manufacturers calculate trash capture flow rates as well as bypass flow rates. So if you have sites that are already prone to flooding during large storm events, you're really going to want to pay special attention to how these devices function and how their flow rates are derived. If you want more information on this, as well as a bit of a better understanding of how flow goes through these devices, we do have another webinar on our saved webinar on our website called Standardizing Trash Capture for Resilient Stormwater Infrastructure. It's a very wordy way of just saying that we've looked at the different ways that people can measure flow rates for devices, and we've found which ones we think are hold the most true to real world conditions. But so after looking at devices' claims for treatable flow rates and getting an idea of the bypass flow rates that are required, we do need to look at the trash retention of the devices. The water board requirements are so that we cannot have trash bypassing below design flows. This is also heavily tied to the maintenance intervals, as a device at capacity will bypass at any flow rate. And so typical design flow rates are calculated assuming the device is half full. In California, that's a typical thing you'll see on the specifications. But in some situations, devices will bypass before then. So here, looking at this image, we can see that this device is about half full, but there's obvious signs of bypass during flows, as seen by this bag, as well as the floatables on the catch basin floor. It also looks like the screen here is breaking down, and so which is leaving openings larger than the required 5 millimeters. Example, this filter here has a torn mesh, and so no longer has any capacity for capture and will be losing the bulk of any materials that enter. And finally, showing here, so some manufacturers claim that if there's a screen over the outlet, then that means that the entire inlet becomes storage. As you can see by these red lines over here, they're meant to be, showing the storage capacity of the inlet. But what we see here is a lot more like what we actually see in practice. This screen has become completely blinded, and which is now creating standing water, which is a vector issue. But also, there's not really a lot of trash in there. There's just a very thin layer across the bottom of the catch basin. So yeah, just to highlight those maintenance lines, and it's showing that, with the screen being blinded, there is bypass happening and the device is not near the maintenance triggers. The other thing I want to highlight is, as you can see by this cup here, it's perched very nicely on the edge of the screen. And that further shows that the device is bypassing, but also at very low flow rates, as similar material would be swept behind the screen and into the stormwater network at flows that are above that 1 year, 1 hour intensity. For just an example, an average calculated trash capture flow rate of inlet filter devices is generally between 2 to 5 cubic feet per second, or CFS. And in a 4-foot wide channel, which is not too much different than a typical curb inlet, 3 CFS could look like water flowing approximately 6 inches deep and moving at 1.5 feet per second, which would carry quite a bit of litter with it. It would definitely carry this cup over the screen and through the outlet. And so, this device is in desperate need of maintenance, but it's not really near the perceived capacity, and it's also bypassing debris downstream, which, as we discussed earlier, that just might be adding to the next city's trash efforts, or impacting the amenity of their downstream rivers and lakes. So kind of what's an alternative to those devices? There are a lot of different inlet configurations, and so having products and configurations that can fit into a variety of inlets is key, because older infrastructure can be very, very interesting. and sometimes engineers had to figure out a particular issue for an inlet. And so it's not designed with trash capture in mind. I mean, most of these inlets you see here were probably made in like the 50s or 60s. But for all of these photos, we were able to find a device that we were able to install, and we were able to do that through careful inlet filter design. We made sure that flows are captured in a way that ensures trash capture, but also doesn't block the outlets or the flow paths into the inlet. And so, as we saw previously, considering how trash capture devices are going to be maintained, once they're installed, that's also very key. And so for catch basin inserts, depending on the catch basin type and the type of filter or screen installed, you can either have hand maintenance or Vector maintenance. The time it takes, the personnel required, expertise, and therefore the overall cost of maintenance activities can vary greatly depending on the inlet access and device type installed. So we popped in a quick poll, or we will be putting in a poll just asking about how maintenance will be going for you guys. And so if you could answer that, we'd be really keen to hear about your feedback on that. And so, some basket style devices, one of the ways can be simply by lifting out of the catch basin by hand, and then the contents can be tipped into the back of a truck bed, as you can see here. And so when this is available, it's an ideal situation because we all know Vector trucks are expensive to bring to site. They're expensive to maintain. Sometimes cities need to use them for other more important things. There's trash capture is just one facet of what a public works team typically does. And so most cities, though, they will have plenty of access to trucks, and they will have a couple guys that they can, lift something out of the grate. And to look at the timing for this, a while back we did a maintenance time trial where we looked after 34 hand maintainable units, and it only took us about 2 hours to maintain them, and they were scattered across the city. Some of the baskets weighed approximately 80 to 100 pounds of wet sediment, so it was a two-person lift, but the maintenance itself was very simple. Just like you see here, you park in front of the catch basin, you place the cones, you lift the grate, and then the basket. You tip it out and replace the basket and grate. In a lot of areas, if the time at the inlet is short enough, traffic management might not be required. You just chuck down a couple cones and away you go. But as with the real world, not all inlets, especially the large curb inlets we see in Southern California, will be hand maintainable from the surface. But there are still considerations to making it as easy and as fast as possible. So in larger curb inlets, hand maintenance is often impractical unless the maintenance hole opening is quite large. And so one way to make sure that the maintenance is really quick and easy is to utilize devices that accumulate debris directly under the manhole opening, as you can see here. You can see that there's the boom inside. You can barely see the basket inside, but it's directly underneath the manhole opening. And so either doing that or making sure that whatever screening device is installed, and making sure that it can be removed from the outlet by hand once maintained. Because a lot of times with leaves and grasses and stuff, it'll break down, it'll stick to the sides, and so you might need to be able to either have a loose fabric that can be shaken to break it loose, or you might have to remove the whole thing and give it a proper scrubbing to make sure that it's not bypassing. One of the key things to look at here is that it only requires a crew of 2, a Vector truck, a pressure washer, and from our maintenance demonstrations that we've done, it's only taken about 15 to 30 minutes to maintain these devices. And from a similar project that we've done, at prevailing wage rates and disposal, we've gotten a bit of information that this location would be about only $135 to maintain. Pricing changes with quantity and the size and type of catch basin. So if projects have more locations, they can often reduce pricing per catch basin as long as they're all nice and easy to access. Conversely, my presentation is just did something. Okay, there we go. So conversely, the most involved method of actor maintenance is the confined space entry type. Um, and so, entering a catch basin is typically going to trigger confined space procedures, especially where there's limited access or poor ventilation, water, sediment gases, or restricted rescue access. And many of these conditions are very typical for catch basin maintenance activities. A typical entry can require a specially trained entrant. They'll need an attendant, a third person to monitor traffic, as well as rescue planning. The safety setup for that typically also includes gas monitoring and harness and tripod retrieval equipment, as you can see on the right there. And so this additional equipment setup can increase the time on site, making the traffic control more involved than other quicker and easier methods of maintenance. Compared to that last slide, just having one person on site for an hour that is confined space certified, you're probably going to be looking at the same cost as the whole maintenance for the previous inlet, not including the extra two people and the cost of the Vector truck. But it's also good to note that if the screening device can't be removed from the catch basin through the maintenance hole from the ground, then you're probably going to have to get in to be able to clean it and scrub it properly. If there's a lot of material that is adhered to the surface. But one thing that is good to highlight, or that I want to highlight, is that when the treatment device is off the floor of the catch basin and utilizes indirect screening, you can often use a lot more of the capture volume of the device, as you can see here. This device is obviously full beyond its maintenance level. It's been a few years not being maintained, but you can see that it still has a lot of trash still captured in the device, whereas direct screening devices will often lose their floatable trash. Once the screen becomes blinded. As you can see here, you see a lot of leaves, you see a lot of sediment, but one thing that you don't really see is any sort of bottles, plastic, or any of those really buoyant pieces of trash that likely would have gone out the outlet. But outside of that, sometimes the catch basins of the stormwater network needs cleaning and maintenance. And so making sure that the maintenance crews can enter the catch basin easily every couple years, roughly, and access the inlets and outlets is a consideration to make. So you want to make sure that there's something that, if it is off the ground and so you can get that full maintenance volume, you want to make sure that you can remove the basket easily and have a good space to access and get into the catch basin. Whereas, say, a screen in front that is bolted to the walls, might be very hard if you have to clear a blockage from the outlet. And so to kind of tie all of this together, the function, the installation, and maintenance considerations of a trash capture device are typically the main concern. But when these costs are extended across the service life of the device, the true value of the specific device can be figured, the full life cycle cost. And so, since life is also what happens after we make plans, we need to plan for contingencies. What happens if the units are damaged, if they're vandalized or stolen? How is it going to be taken care of? Do the devices require full replacement, or will they require intensive repair on site? Or are replaceable components available? And what's the warranty and the conditions of that warranty? If a device is very low cost to install but is only warranted for 3 years and requires very expensive maintenance, confined space entry, then the life cycle cost is going to be a lot larger than a device with, say, an 8-year warranty, such as ours, that has a slightly more expensive supply and installation. I won't say that we're more expensive for supply and installation, but we do have an 8-year warranty, and the thing that we really focus on is very simple maintenance, so that no matter what, when you're looking at these devices for the next 10 years, maintenance is very low cost and easy to do. And so now that we have an idea of what to look for in our devices, we can look at how to implement them. So we'll be looking at bidding requirements as well as best practices and other pitfalls to look out for, as well as some real world projects that I've been involved in myself. And so starting with the bidding and pure procurement process, this city is about how cities move from that compliance planning into procurement. And we'll take a quick look at competitive bids versus sole source, as well as some guidance on specification, drawings, as well as submittals. So unlike this image, we can set up our bids to be successful well after the project finishes. I apologize for the wall of text. It's kind of there just to be a bit complete and be a resource to review afterwards, but I'll kind of summarize it here quickly. Competitive bids are going to be, starting with competitive bids, those are the most common ways that municipalities will procure trash capture devices. And a competitive bid works best when the city defines the outcome clearly and provides good inlet information, as well as lets qualified bidders propose compliant solutions. But to counterpoint that, strong bid documents upfront really help to make sure that the upfront costs don't get in the way of finding the best product for the city. Again, we have to have everything installed within the next 4 years up to 2030. But that means that from then on, if we are completely installed, we're going to be having to maintain those. And so just low install costs shouldn't be the bottom line. So on the other side of it, sole source comes along when there's a specific requirement that a city needs, such as quantitative removal results or unique site constraints. A sole source project also needs to show that why that specific solution is necessary and not just preferred. For instance, if a city can get additional credits for sediment or nutrient removal with their trash capture, a device with third-party testing data showing these removals are possible could potentially be a reason for a sole source specification. The process for this, can be a bit time-consuming, and there are a few steps to it since it requires approval from the governing body. But we have assisted others with this, and it has yielded good results for the city. But with this in mind, we are going to focus on competitive bids during this presentation. And so a competitive bid allows pretty much anyone to come to the table, which is great for fairness and competition. But as we've seen before, there's a lot to consider, and it can be easy to miss things when comparing a lot of different products. Generic specification drawings or documents that are calling out key requirements can be very helpful to prevent ambiguity. And considering material and submittal requirements can also set you up for good experiences after the initial project is completed. Here, we can see an example of a grade inlet with a curb entry specification drawing for a trash capture basket. Note that in addition to the drawing, there are also written specifications for things like basket weight and removability to help make sure that maintenance is easy. As well as any sort of regulatory and flow requirements such as vector access or even lab testing, just to make sure that for your specific site, you can be confident that the device will convey flow properly. There can also be material specifications which ensure longevity and robustness. Here's a similar example, but this one is for a curb inlet with easy manhole maintenance specified. And you'll see a lot of similarities between it and the previous arrangement. But the key difference for this drawing is that the filter is called out to be located under the access opening. And what this does is gives a visual indicator to the bidding contractor that the city expects to maintain these devices without having to enter the catch basin. And so these drawings we've seen in practice that they're a really good visual example of best practices that and so it kind of prevents ambiguity. But there are also some other different levels of specification requirements that we will look at. For these next few slides, again, there's a lot of information coming up. And so for the sake of time, I'll be going through quickly so that we can actually see these items more in a real life case study. But again, if you want the slides or watch the recording after, these are available for a bit more in-depth instruction. But so when you're looking at the pre-bid or essentially the site information for a project, the more information that we can get up front, such as inlet photos, measurements, or site constraints, as well as any sort of existing devices that may need to be removed, it's incredibly helpful to make sure that contractors can bid appropriately. When there's insufficient pre-bid information, contractors have to make their best guess, and they either put extra fat into the bid, or the other side, they bid very low, and then they just have to ask for a change order when something comes up that they couldn't plan for. And so then it can create unplanned costs and add time and uncertainty into those project completion timelines. And so good device and material selection is about, the key thing about it is avoiding a purely lowest cost device mindset. For full trash capture retrofit projects, the device does need to be certified, but it also needs to fit in the inlet, needs to handle the required flow, and above all, it needs to be practical to maintain. And so for some of these items, reliance on good pre-bid information is required. The best specs are going to focus on performance, as well as hydraulic and bypass capacity, corrosion-resistant materials, as well as warranty support for whatever can happen on site. And so a good bid can still allow flexibility, but the least desirable approach is vague language or forcing one type of device into every catch basin. So with installation and maintenance parameters, they build on device selection by showing why installation and maintenance details need to be defined before award. Even a certified device can create issues if the contractor goes into installation blind, as they will often try to make installation work with what they have, rather than considering the maintenance or access implications down the track. And so with that in mind, best practice is verifying every structure before fabrication, defining cleaning and disposal responsibilities, and making sure maintenance crews can actually inspect and service the device safely. And from what we've seen, don't assume every contractor will work to an appropriate safety standard. You do need to include that as well. And then from there, we need the post-project information. As you can see with moving to those regional permits and there being a bit more stress on reporting and that kind of information, making sure you get appropriate installation documentation, getting inspection and verification that the devices are installed and they're installed correctly, and making an inventory of those devices just helps make sure that for whatever your reporting requirements are, you're not going to have to go back out and do it yourself and, take all of that time. Separately, whereas if you can take care of it as part of the installation process, it'll be a lot quicker. And so to tie it all together, this is kind of a general workflow for projects in terms of best practice, good options, and what is least desirable. And so depending on the information readily available and the specifics of your project, you can use a bit of a mix of best practice and good options, but you really want to avoid these least desirable ones. Because as you can see here, a lot of times it'll set you back, or you kind of run around in circles until you have enough information that you can actually go and put in a good bid or, finish the actual project. And so looking at a couple options or a couple examples of least desirable projects, this is an example of where no information was provided at the beginning of the project. And so, the contractor had to provide catch basin information, they had to provide flow rates, they had to provide location. Contractors typically don't calculate for flow rates, so it might be a bit of a risk having them calculate flow rates and then decide what the appropriate device is for an inlet on site. And here's an example from an RFI where there was not really any information that was provided. We were looking for dimensions or catch basin sizes, and that information just wasn't available. And so the bids ended up getting rejected, and now the person that's in charge of it is kind of having to start at the beginning. So now it's time to look at some case studies that have gone pretty well. And so before we get into that, in a lot of cases, municipalities in your area might have already conducted pilots or have experience with some trash capture devices. It's a good idea to ask them about their experience and see what feedback their public works teams might have and take into consideration when you are selecting devices. We've seen cities provide maintenance demonstration where they have a selection of devices installed and they invite other cities to come and see as well. So we recommend looking and trying to organize those if you can. And so, outside of that, a lot of cities do tend to want to have their own pilots. And while most manufacturers are happy to help, pilots do last 6 to 12 months, and so aren't great in a pinch, but they can be really beneficial for helping your public workers in your city understand the devices and how they maintain themselves. And so the first case study that we're going to go ahead and look at today is our case study for Thousand Oaks. And one of the key things for this project, cities aren't hiring more people just for the addition of maintaining trash capture devices. And so the key thing they wanted was ease of maintenance as well as robustness. So you can see here we installed quite a few EMA devices as well as hand maintainable devices. There was 22 inlets total, curb as well as grade inlets, a bit of a mix, and they have old and non-standard drainage. But they worked with us while they were getting ready for the specification so they could make a strong specification and make sure that they get exactly what they need and what will be easy for them to look after for the years to come. And from there, the project had everything installed and they were finished ahead of schedule and on budget. And part of that came, again, from working with us. They were also able to give us the best pre-bid information. They gave us measurements of every single inlet, and especially for these really custom inlets like we saw earlier in the slide, they gave us a bit of specific measurements. And so what that allowed is the installation contractor, we were able to make a detailed design and a plan going in so that they didn't have to come in here, wonder what the heck they're going to do, and then figure it out. So that's how they were able to get that done so efficiently. So now moving on to a different city, which is Wildemar. It's a bit of a more newly developed city, has new infrastructure, a lot of standardized, standard for public works curb inlets, and it only had a few tricky inlets out of a total of 49 large curb entries, up to 28 feet long. And having, a modular device such as our EMA kit, made it so that they had a lot of flexibility on site and they were able to use the parts and components that they had. And they actually needed minimal information from us to get everything taken care of. And again, they were looking for durability as well as ease of maintenance for the project. And so, since Wildemar had a bit of newer infrastructure, their pre-bid information was on the line of like what's good and best from the previous slide. They gave us maps with the location, inlet types, and general dimensions. But since they were all brand new inlets and they were all pretty standard, they didn't actually need to give us detailed measurements and photos of every single inlet. But they did make sure that the inlets, they gave us a little bit of information so we could quote appropriately or bid appropriately. But they were all labeled, easy to find, and easy for us to work with. And so for this one, again, the installation went smooth for those 49 locations. The city had given Swiss 20 working days to complete, and they finished it in just 12 days of effort. And they even, had a few weddings and other things that they had to get taken care of in the middle. And so it was great that they were able to do that and still just smash it out of the park. The other thing that they did is they provided an installation report, with images and locations of all the units so that they could put that into the asset database. And the other thing that they did is they added some of our curb inlet markers onto the curb so that if a public works person is going up to the inlet, they can tell that a device is installed in the inlet without even getting in to look at it. So that way they know how to, they might need to proceed a little bit differently than if they're just attending a catch basin with nothing inside. And so I've talked about this one a little bit in the past, so I'll go through pretty quickly, but our retrofit with Temecula is a great example of a sole source specification. They had 124 inlets. They calculated the catchment areas and the flow rates. And as you can see here, so these were the 10% that they were concerned might be above the trash capture flow rates for standard devices. You can see here, like this inlet is about almost 7 CFS, and it was just about, it was like a 7 or 10 foot curb inlet, which is quite a bit of flow. But since they provided measurements and photos of each inlet, it made it very easy for us to be able to come up with custom solutions, whether or not it was adding extra baskets in, or we could change the angle of some of the flow conveyance components. And then from there, we were also, since we were building that out and working with them, we were able to help them with their maintenance planning. We told them it's like, these are the devices that are hand maintainable, these are the devices that are maintainable from the ground. Or if, for some of them that were had very high flows, there was one or two where it was like, okay, this one's going to, require a bit more involved maintenance, and this is how you can do that. And so when it came down to it, they were able to maintain all of their inlets. They let us know about a month ago that they were able to maintain all of the inlets within a 2-week period, which is pretty incredible. And just kind of to go and show how the device works, this is one of the devices in a 10-year storm flow event. And again, just kind of showing how it's not just a certified device, but it's also a device that's built properly. You can see that there's a lot of water coming in from both sides. A little bit of debris on those screens on the top of the trough. You can see there's a bit of material here on the inside that is still being held onto. We got a plastic bottle here. We got a bit of cardboard. It looks like we have a plastic cup of sorts, and they're still being held on. So that means that they're not bypassing and being conveyed down to become somebody else's problem down the line. And so, yeah. So while even though some devices might be certified, it's good to look at other things. And so, in final summary, we'll get on to some questions. We looked at the regulatory context, regional permit considerations, device types, procurement, pre-bid information, as well as some case studies. But the key takeaway that I want you guys to have is just the successful projects depend on clear compliance goals, site-specific design, maintainable devices, as well as strong procurement documentation. And if you have any questions for us about any of that, if you need a budgetary estimate, or if you are interested in a pilot project with one of our devices, or you want help with, making sure you get a strong specification for your project, let us know. We're very maintenance focused, and we're very focused on the long game of trash capture. Thank you. That went a little bit longer than I expected, so we have a little bit less time for questions, but I'll go ahead and get into them. But if you do have any questions, there's my email as well as Landon's email. He might be turning on his camera here in a second, but he's also a sales engineer with us, and between the two of us, I'm sure we can answer anything you guys have. But looking at Q&A from Jonathan, do you recommend bidding the filter system separately from the catch basin in new construction? In the Wildemar example, the filter system is on its own. No, not necessarily. I mean, it depends on how you do it. So, capital infrastructure projects are a really great way to install trash capture devices and make sure you don't have to go back to it later on. So we see a bit of a mix. If you have a lot of city streets and already built up infrastructure, definitely you'll have to retrofit at that point. But if you can get it done with everything else by a certified contractor, I think that's a very efficient way to go for it. Let's see here. Any other questions? Yep, so Nicola has shared the webinar that I mentioned earlier in the chat, which is great. It goes over, if you'd like to nerd out and if you are really concerned about how these trash capture devices, whether or not they will impede flow or which ones might be at more of a risk for your sites, we do look at quite a few different ways that trash capture flow rates work and how different configurations can convey flow separately. So that's a very good way to go. If you were, wanting to get into the weeds. Perfect. And so outside of that, One thing that I will go ahead and show you guys is, if it's something where you do have a project or something you're curious about and you want to get our input, we do also have a measure up form that we use through ArcGIS Survey 123. So, we can share this with you if you'd like. This way we can get all of the measurements and the photos and details of the catch basins. We can get measurements based on the catch basin type so that we know exactly what we're looking at, and we can give you a good budgetary estimate, as well as just let you know what you're looking at. And it's an easy and efficient way to get that information for your bids. And yeah. Any other questions about the products or anything just outside of what we've talked about? Love talking about the litter trap. So if you have any questions about the materials or the maintenance requirements, always happy to go into that as well if any of you are curious. Yeah, outside of that, I guess I will tell you guys, with most, with full trash capture and track one compliance, you do need to just maintain yearly. With what we find with our litter trap devices is generally 1 to 2 times a year is all that's required for maintenance. If you have a whole bunch of trees or organics that are going to be going in, you can, we would recommend maintaining it spring or fall time, when most of those organics are falling onto the ground and getting washed into the catch basins. But it really always depends on the site. If you have somewhere that's just getting a ton of bottles or stuff, say if it's near a stadium, and it's going to be very peaky for when it's getting loaded, you might have to consider that. But with how we, with how we set up everything and with how we get, try and make sure we give all of the information for our devices so they can come up with a good asset register. There's been some cities that have been able to get really good maintenance efficiencies by keeping that in. So there's always a smart way to do things. We're always happy to share that information or get you in touch with somebody else. Question from Matt Wiesenberg. Hopefully I say that right. Well, what's the performance of these devices in cold climates? They do very well. So, I mean, we do install them in Canada, and all of the components are treated. So the seals are UV treated, so they can also handle extreme heat, plus 40 degrees Celsius or well over 100 degrees, but also to minus 40, and so I can share some photos of devices that have, snow and ice, piled up inside. And, the only thing that you will consider is as soon as that snow melt starts coming through, you'll definitely need to maintain it. But yeah, extreme cold doesn't make a difference as far as the longevity and the life cycle of the device. For traditional sized capture devices, can these devices be cleaned up by dumping into a truck, or is a vac truck used? Whatever you prefer. Yeah, you can, as you saw both of there. So this, that basket that is maintained within that slide, I'll put it back up on the screen. But that basket is the exact same size for the grade inlet, as well as the same basket size that's used in the M inlet. And as you'll see there, they're both, you have both options. One thing that's really good to note is that the basket has battens on it. And so what that does is that prevents it for the basket from getting sucked up into the Vector truck. It makes it so that it's malleable and that it can move around and shake loose any sort of captured material. But yeah, if you get a Vector truck, you crank it up on the high settings, so you got some really impacted sediment, that is just fine. So we'll just go here. Yeah, so this basket here is the exact same basket that is used here, and It's actually also the same basket that is used here. So as you can see, we kind of have a modular system. We don't want to have a whole bunch of different products. We want something that can work in a lot of different ways, just so that it keeps costs low for you guys. So however you need to maintain it, you can. We just wanted to make sure you have the options to keep that efficient. Cool. And so, yep. And as Nicola said, we do have our drawings on the website as well as a lot of other great information. So from Michael True, the product works in pre-construction. We do have additional performance liners that you can add on. So one of them is a geotech style liner, which is made to the same ASTM standards as witches hats or any of those other devices. And you can use that in conjunction with a Lititrap during pre-construction or during construction. And yeah, and then once the construction's over and you move on to post-construction trash capture, you simply remove the liner and dispose of it, and then you have your trash capture device. So you kind of get you can get two birds at once with that one. If you have any questions about that, Nicola is onto it. Got the construction liner. So that's one of the options. We have also another sediment liner. If sandy coarse sediments are an issue or something that you're looking to capture. Sorry, just saw the GIF put in the chat. But yeah, so we have other liners. If you have a specific treatment requirement, let us know. The Lititrap can't do everything, but we've tried to make it so that it can for the right situation, it has the right options to help. Good question, guys. From Ken, what is a rough installed price per catch basin? So installed prices are tricky. That's very dependent on where you're at, how many devices, because you're looking at, there's the procurement, but then there's also like the mobilization and traffic setup. So I can say for a typical grade inlet, you are going to be looking at somewhere between like generally $400 to $700 per basket that goes inside, depending on size and different things like that. And then installation for a typical grade inlet, I would say, is about, is generally about $200 to $300 per unit. And then there's mobilization, which then scales with the size of the project. For larger curb inlets, they're obviously bigger products, so they're going to be a bit more expensive. Those run from, for like a 7-foot curb inlet, you can get one of those for about $1,200, whereas like a 14-foot is $1,800, and then it kind of goes up with the size of the inlet there. And yeah, I would say that installation for just the unit is generally probably in the range of about $1,000. It only takes, with a good contractor, it only takes about an hour and a half to install. And so, yeah, those are very, very basic information. But if we work with a lot of installation contractors. So if you do want specific pricing for where you're at, we can get in touch, with whoever works in your location, in your area, and get a bit more of a budgetary estimate. No strings attached. Cool. And question from Will. Do you provide maintenance training to public works staff? Yeah, absolutely. We can do installation training, maintenance training. That's part of what we do. So whether or not it's online or if it's in person, we're more than happy to show up, get our hands dirty, and show you guys what's going on. We won't necessarily climb into the inlet for you if it's a curb inlet, but we'll absolutely, we can give you guys some structured guidance on how that works. And yeah, thanks, Nicholas. We do have operation and maintenance manuals for products, and we do have a lot of videos. I will say we do have it's Stormwater TV is the name of our YouTube channel, and there's a wealth of information on there that is available. So if you are looking for anything about maintenance or how products look, or even just some of our webinars, those are available there. And there is a link there, right in the chat. Any other final questions or concerns, comments from anybody while we got in the last minute or two? Alrighty. Well, yeah, great. Thank you very much, everybody, for joining in. And yeah, feel free to get in touch with us. There's our emails again and our toll-free phone number if you'd like to give us a call. Are you having two that's stated on them? Not that I know of, Anthony. I don't know where that might have come through. It might be something with the different time zones. We got people from all over the states, as well as quite a few people from New Zealand attending. But thank you very much, everybody. And yeah, thanks, team, for backing me up so well on that. I hope to talk to all of you soon, and have a great rest of your day.